Picture a city built on the spine of a mountain, in a place that gets rain more than 200 days a year, sitting almost directly on top of two active fault lines. Now picture that city standing for over 500 years without a single major structural collapse, while colonial buildings built centuries later, with iron tools and European technology, crumbled and had to be rebuilt again and again. That is not a coincidence. That is not luck. That is Machu Picchu. And the reason it is still standing has almost nothing to do with what you can see when you visit. It has everything to do with what is buried beneath your feet. Most people who travel to Machu Picchu leave thinking about the same things. The misty sunrise over the ruins. The green terraces stepping down the mountainside like a staircase for giants. Maybe a llama wandering between the stone walls. What almost nobody leaves thinking about is drainage. And that is exactly the problem, because drainage is the real story. Underneath those postcard-perfect terraces is one of the most carefully engineered water management systems built anywhere in the world before the industrial age, and understanding how it works changes the way you see the entire site. Let's start with a basic question. Why did the Inca build terraces at all? The obvious answer is farming. Flat ground is hard to come by on a ridge that drops away on both sides into a river gorge, so cutting the mountainside into steps created usable land for growing maize, potatoes, and other crops at different altitudes, each with its own microclimate. That part is true, and it matters. But it is only half the answer, because if the terraces had only been about farming, they would not have survived. A region that gets torrential rain for most of the year will tear apart loose, sloped earth in a matter of seasons. Waterlogged soil on a mountainside does not just erode. It slides. It liquefies. It takes the retaining wall with it. The Inca knew this, and so the terraces were never simply agricultural platforms stacked on a hillside. They were built as an engineered response to gravity, water, and unstable ground, all at the same time. Here is what is actually underneath a Machu Picchu terrace, and this is the part that genuinely surprises engineers who study the site. It is not just dirt piled behind a stone wall. Each terrace is built in layers, almost like a filter. At the bottom sits a base of larger rock and rubble. Above that is a layer of smaller broken stone and gravel. Above that a layer of sand. And only on top of all of that is their actual topsoil, the kind you would recognize as farmland. This is a graded, coarsening fill, and if that phrase sounds familiar, it is because it is essentially the same design logic modern civil engineers use today behind retaining walls and in systems built to manage stormwater. You let water pass freely through the coarse material at the base, so it never builds up pressure behind the wall, while the finer layers above keep the soil in place for planting. The American civil engineer Kenneth Wright, who led a major research permit-based study of Machu Picchu's hydraulics in the 1990s, spent years mapping this system with his team, and his conclusion was that a huge share of the total construction effort at the site, more than half by his estimate, went into work that nobody visiting the ruins would ever see. Buried foundations, packed fill, and channels carved to move water away from anything that mattered. That underground work did not stop at the terraces. Wright's team documented over 100 drainage outlets built into the site, along with subsurface stone-lined channels running beneath plazas, pathways, and courtyards, all designed to pull rainwater away before it could pool or soak into the ground and destabilize a structure. During his excavation of the main plaza, Wright's team dug down about 9 feet and found roughly 3 feet of carefully placed topsoil sitting on top of layered stone and gravel drainage material, essentially the same terrace logic applied to the ceremonial heart of the city. The point of all of it was singular and practical. Water is the single greatest threat to a structure built on a steep, wet mountainside. So get out of the way as fast and as efficiently as possible, using nothing but gravity. No pumps, no pipes in the modern sense, just carefully graded stone doing exactly what it was designed to do. The results speak for themselves. Machu Picchu sits in a cloud forest that receives heavy seasonal rainfall on a ridge crisscrossed by fault lines, and it has weathered roughly 5 centuries of tremors, storms, and seasonal flooding, with its terraces still functioning. Wright's research group described the Inca water system there as achieving results that stand up to comparison with much later engineering, all built using bronze and stone tools, human labor, and most importantly, Careful planning grounded in direct observation of how water actually moves through soil and rock on that specific mountain. That last part deserves emphasis, because it is the real explanation for how a civilization, without written language and without modern instruments, pulled this off. It was not magic, and it was not a mystery. It was generations of accumulated, hands-on engineering knowledge, tested empirically on real terrain, passed down, and refined by builders who lived with the consequences of their own mistakes. Now let's talk about the stonework itself, because this is the piece that tends to blow people's minds when they see it up close. Machu Picchu's finest walls are built using a technique called ashlar masonry. Each stone is individually shaped and worked until it fits so precisely against its neighbors that no mortar is needed to hold the wall together. And in the best examples, you genuinely cannot slide a knife blade into the seam. The Inca did this using hammerstones, harder rocks used to gradually pound and shape softer stone into form, along with bronze tools, wooden levers, ramps, and an enormous amount of trial, error, and patience. Many of the retaining walls are also built with a slight inward lean, called battering, which lowers the center of gravity and makes the wall more resistant to the kind of lateral push that comes from an earthquake or from wet soil pressing outward. When the ground shakes, these dry stone walls do not behave like a single rigid slab that either holds or shatters. They flex. Individual stones can shift very slightly against each other and then settle back into place, dissipating some of the seismic energy instead of concentrating it into one failure point. It is a genuinely elegant piece of structural design, and it is well documented by architects and engineers who have studied the site's masonry directly, not something that needs exaggeration to be impressive. It is worth being honest about the labor question too, because it is often where these stories get pushed toward the sensational. Moving multi-ton stones up a steep, forested mountain ridge without wheeled carts or draft animals capable of hauling heavy loads at that altitude was an enormous undertaking. But it was not an unexplainable one. The Inca Empire ran on a labor system called the MITA, a form of rotational public service in which communities across the empire owed periods of labor to the state, in place of taxes paid in goods. This gave Inca rulers access to organized, large-scale, coordinated labor forces for major infrastructure projects, roads, terracing, temples, and estates like Machu Picchu, without needing money economies or written contract to manage it. Archaeological research into the site's construction sequence suggests it was likely built in phases over a period of years under the Inca Emperor Pachacuti, who ruled starting around 1438, with Machu Picchu most likely constructed around the middle of that century as a royal estate rather than in one continuous rush. Thousands of workers, organized labor drawn from across a rapidly expanding empire, and generations of accumulated stoneworking skill are a fully sufficient explanation. It does not require lost technology or an older, unknown civilization to make sense of what is standing on that ridge. It requires taking Inca engineering seriously on its own terms. So, why does Machu Picchu still feel mysterious, even to people who have read about it? Part of it is simply that the Inca left no written technical manuals. There was no written language in the modern sense, so we do not have step-by-step Inca engineering treatises the way we might have Roman ones. What we do have instead is the physical evidence itself, and in recent years that evidence has only gotten richer. Ground-based surveys, laser scanning, and detailed hydrological fieldwork by researchers, including Wright and his collaborators, have mapped the terrace fill layers, the fountain systems, the canal gradients, and the drainage outlets in a level of detail that simply was not available to earlier generations of archaeologists working mostly with shovels and notebooks. What that research keeps confirming, again and again, is not that something impossible happened at Machu Picchu. It is that Inca engineers were doing rigorous, empirical, highly competent civil engineering, centuries before the field had that name, using direct observation of their own mountain instead of textbooks. There's also a quieter finding buried in Wright's research that deserves more attention than it usually gets, because it says something about how these builders thought. His team found that the main water canal feeding the site was built with more capacity than the springs supplying it could actually produce, even at peak flow. In other words, the system was deliberately over-engineered, designed to handle worst-case conditions rather than average ones. That is a specific design philosophy, the same one modern engineers are trained to apply when they build in a margin of safety. And finding it in a 500-year-old stone canal tells you something real about the priorities of the people who built it. They were not just solving the problem in front of them. They were planning for the problem they had not seen yet. None of this is meant to strip the wonder out of the story. If anything, the real explanation is more impressive than a mystery, because a mystery lets you shrug and move on, while the real answer demands you actually credit the people who did the work. What the terraces of Machu Picchu represent is not an unsolved riddle waiting for aliens or a lost supercivilization to explain it away. It is a masterclass in reading a landscape, understanding water, and building with total respect for the forces that would otherwise tear the mountain apart. The Inca did not fight gravity and rainfall. They designed with them, layer by layer, stone by stone, until the mountain itself became part of the structure holding the city up. The next time you see a photograph of those green terraces stepping down toward the Urubamba River Valley, try picturing what is underneath instead of just what is on top. Picture the graded stone, the gravel, the sand, all doing quiet, invisible work every single time it rains, exactly as it has for more than 500 years. That is the part of Machu Picchu that almost nobody talks about, and it is the reason there is still a Machu Picchu left to photograph at all. The Inca built a farm. They built a city. But underneath both of those things, what they actually built was a machine for surviving water, and it has never stopped running. If you found this as fascinating as I did digging into it, let me know in the comments what ancient engineering feat you want covered next, and subscribe for more deep dives into the real science behind history's most impressive structures.